New problem, and we're going to begin the same exact way. We're going to begin with the question sentence. So the question sentence here reads, if 70 people were surveyed, again, conditional information, what is the difference between tea and coffee preferences? Okay, what is the difference between tea and coffee preferences? So here's how we're going to structure this. We have 70 people were surveyed, and then we want to know the difference between tea and coffee. So that's how I'll write that down. We have 70 surveyed being compared with the difference, again, blank, being the difference between tea and coffee. Everybody confirm this for me. Difference means subtract. Is that true for you? Difference means subtract. Absolutely. So we'll take the difference between tea and coffee. So I'll just write that down like this with this bar on the left and the right. Just saying, just in case if coffee is greater or tea is greater, I'm just going to take the difference. I'm not going to worry about negatives and positives. Just going to take the difference. So that's what I'm going to want to compare down here as well. Watch here. In the first sentence, it says, in a survey, 8 out of every 20 people prefer tea over coffee. Let me write that down. We have 8 compared with 20. 8 prefer tea out of the 20 people that were surveyed. Everybody, which of these two values, the 8 or the 20, can we use immediately in the proportion? Which of those values is immediately ready to be used? The 8 or the 20? Now, if you're thinking the 20, you're correct. If you're thinking the 20, you are correct. The reason is, when we're setting proportions up, we have to compare the same things in the same way. So notice here, we have 70 surveyed compared with the difference between tea and coffee. Those are the two things being compared. I want to see if I can get the ratio part for surveyed and the ratio part for the difference. If I can get those two things, everybody, I'm good. One more time. It is all about comparing the same things in the same way. So I'll go ahead and write blank surveyed and then blank for the difference between tea and coffee. If you stick to these principles, it can be very straightforward, very easy. So check it out. I can place the 20 right there because, again, 20 were surveyed. Then you might be asking, wait, how am I actually supposed to get the ratio number, the part here, for the difference? Well, here's how. Here is exactly how. My friends, if we survey 20 people and 8 of them say tea, how many of them would you expect to say coffee? If 8 of them said tea, how many are left to pick coffee? 12. Exactly. Because when you think about it for a moment, 8 plus 12 makes 20. So if 8 picked tea, that means 12 picked coffee. So everyone, does that mean I'll take the 12 and put it in there? Or is there a different number that I'm supposed to put in? Who knows? Let's see who knows. Because remember, everybody, what we're trying to compare with is the difference between tea and coffee. So who thinks it's the 8 or the 12? Which one is it going to be? Which one should we plug in? Well, it's a moot question. It's a trick question. It's neither. Everyone, follow along with me. Follow along. What does it mean to take the difference between tea and coffee? What does taking the difference mean, everyone? It means to subtract. Exactly. If we have 8 folks choosing tea, 12 folks choosing coffee, what's the difference going to be? What's 12 minus 8, everyone? 4. That is the difference between tea and coffee. That's it right there. So I'm going to plug the 4 in right there, and we're good to go. We're done. I can place an X right here because I can be certain that I'm comparing those surveyed with the difference between tea and coffee. I've set it up properly, and once I solve this proportion, whatever x is going to be the answer. Just like that, straightforward. Let me show you here. So we'll go ahead and do 70 over 20 equals x over 4. Let me make a little more room for myself just in case I need it. And then we'll go over here and write that out. 70 over 20 equals x over 4. We'll cancel things out to make life a little easier for ourselves. So that's going to be 7 over 2 equals x over 4. And if you take a look at where we're at right now, we're actually pretty fine because we can go from 2 to 4 by multiplying by 2, which means from left to right up top as well will be times 2. Of course, we can cross multiply and divide to get 2x equals 28. Divide by 2, we would get 14. Same thing over here. 7 times 2 is 14. But nonetheless, everyone, the correct answer here is answer choice B. And here we go with the next example. So in this example, we have x minus 7. All of it is being squared. So remember, everybody, anytime any value is squared, it is the same as that value multiplied by itself. So because the entire x minus 7 is wrapped in a parentheses being squared, that means that we have x minus 7 times x minus 7. Again, the same thing multiplied by itself. So now that we have that going on, we're going to move forward like we have been with the distributive property. Everything from this parentheses multiplies with everything from the other. Here we go. We have x multiplied by x squared. X multiplied by negative 7, negative 7x. Then we're going to look to the negative 7 here. And let me just go up top. So negative 7 multiplied by x is negative 7x. And then negative 7 times negative 7. Well, a negative times a negative is a positive. And 7 times 7 is 49. So that's going to be plus 49. And there we are, everybody. And just to be consistent with the colors, give me 2 seconds. I'll go ahead and swap that out with blue. But that'll be plus 49. And now that we're here, it's the same old song and dance. We have distributed, so we've expanded. Now we're going to combine like terms, which exist between each of these negative 7x's. Now be careful, these are not going to cancel out. They're not going to cancel out. If we have negative 7 of this something, and then we take away 7 more, this is how we want to think about it. We want to think about it as, hey, we're already backwards 7 steps. Now we're going to take another 7 steps in the backwards direction. Everybody, negative 7 minus another 7 gets us to what number? Yeah, it gets us to a negative 14. Because if we take 7 steps back and then another 7 steps back, we are going backwards or negative 14 steps. So that's a quick little crash course when it comes to working with negatives. As always, we have those resources for you to work with to really refresh and build that confidence. So just remember that even if that negative part is confusing, you are still doing a great job when it comes to learning about distribution. But the correct answer here for this one, my friends, is going to be answer choice B. And there we go. Again, everybody, keep learning from those mistakes. Keep learning from those mistakes bit by bit.